A sub 1 minute benchy, you say? How about a benchy on a benchy? Okay, before I was about to chase a squirrel off a squirrel before I even got into the first couple of sentences of the stream. So, if I don't do this now, I'm going to forget it. I am going to sidetrack myself, derail myself, and fall off script. So, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, okay, I'm going to run away from the camera right up front. First thing, not far, not going far, just coming over here because of something that Amanda just said in the chat, which was, I am watching a video of a sub 1 minute benchy, to which I give you benchy on a benchy. I sent this job to the printer last night and it was there sitting on the print bed this morning. I wonder if I can, okay, I'm going to switch to overhead. Oh, I forgot to turn that camera on. Once again, I did that last time too. I am a black square. Peace. So this is, yeah, this is stuff for later. Benchy on a benchy. It's when you search for benchy on Maker World, I think it is, where this one came from. There are a whole lot of different variations. There are things like the benchy container ship and all the fun things. This one's got a little hole in the back for a flag. Does the original? I don't remember that. And this one, benchy on a benchy, just seemed funny. And I had a special request to print this one last night. So I sent it to the printer. Oh, hang on, Henrik. Hang on. I've just, seeing that reminded me, I've got to do this. I have to open Cast Note. I have to make sure the system volume is turned up. Go to login. Log in. Sign in. It says on the big button, the big red button. Here we go, streaming now, logging in. Okay, I'll get back to saying hello, good mornings in just a moment. For now, what we've got is this from Henrik. A banana peel? You're hoping I fall over? I think I said someone needs to print a life-size benchy and install a 3D printer. Yeah. Thank you, Henrik. Thank you for the banana peel. Hopefully I won't slip on it. Yeah. So, yeah. Anyway, last night I had a request from someone to print a benchy. It was kind of a spur of the moment thing of, hey, have you ever printed a benchy? Yes. Can you print me one? Yes. Pulled it up on the laptop and sent the job to the printer and then came and picked it up this morning. So, benchy on a benchy. I want to see benchy on a benchy on a benchy. Now, with Vic's work, of course, we could do a tiny, tiny little benchy that sits up on the top of this benchy. How many benchies deep can we go? Not quite recursive benchies, not by the strict definition, but still pretty cool. So, benchy on a benchy. Just hosing off the soot. Yeah, Vic says, with you in 20 minutes, just hosing off the soot. So Vic has been on a turning money into loud bangs trip this morning. Is on a oh, Stephen says that benchy on a benchy is on a bench already. That's true. It's benchies all the way down, Mr. Hoyle. So, looking in, hang on. Where's my mute button? There we go. So, according to Cast Note, I need to say good morning to Tinker001.
Only thing that's gonna slip today is the belt on those gears.
The belt on those gears? Yeah, maybe. We will get to that. We will get to those stepper motors in a moment. Good morning to Crispian, to myself, because I am in the chat. Amanda, Wagon Loads, Henrik, Princess Fiona, Mr. Fixit, Grant Mazel, Stephen George, Immy, John Whips, Stephen4479, Simon CBR, and Vic Oliver. Welcome to the chat. Oh, Wagon Loads. So, Wagon Loads says, sorry I missed the beginning. I was speaking with my brother who has been in hospital since April. Wow, that is quite a stay, Wagon Loads. I hope your brother is okay. Although that is kind of a silly thing to say when someone has been in hospital for, that would make it something in the order of 4 weeks now. It is yeah, whatever is going on is obviously serious. That's a thing. So I hope he recovers quickly, is more to the point with whatever is going on there. Oh, Wagonlad said he was sounding good, breathing issue. Okay. Okay, good. Hopefully recovering. Amanda said, as I watch the live stream, I'm packing my bag for a cruise on Monday for 5 days. Going on a cruise. What's it a cruise? When you say cruise, I assume that you don't mean getting into an old Monaro and driving down Chapel Street on a Friday night. No. When you say cruise, I assume you mean a big floating box on the ocean. Is that the sort of cruise? Now, what is going on in the chat? All right, so the theme for today's stream is going off topic, because I figured that just for a change, what I wanted to do was have a stream where I do not stay rigidly laser focused on one particular topic. I want to have a stream where I just chase the squirrels. So I'll probably do a couple of different things. I have some, it's kind of sad news about RepRap Micron, but it's fine. It's fine. I just broke something. That's all. Simon, say nothing different. No, it's totally different. I'm going to just, I'm not going to stay on topic this time.
So, normal stream then.
Yeah. Okay. What am I looking at? I'm looking at pieces of RepRap Micron just to my right. We will get to that. The thing is that because for the last little while I have been alternating streams between RepRap Micron and Beetlebot, other things have just sort of smushed their way into those topics and pushed those topics aside. And when
Mrs. John, when will you go on vacation again?
Henrik, I assume you are talking to me. When will I go on vacation again? That is just being discussed at the moment, actually. There is a possibility that there are several ways I can answer that question. I am probably going to be going to Canberra soon. Kind of a vacation, sort of a vacation. And that's a briefish trip, like over a weekend with travel on either side of the weekend. So visiting Canberra soon, in a few weeks, something in that order. And then possibly going first week of August, going on a diving trip, possibly. Not booked yet. This is just, at the moment, it is a point of discussion between myself, one of my sisters, who many of you will know, Jackie, and one of Jackie's friends, and possibly another of her friends, So that is the group that I have kind of glommed myself onto, because they got themselves into a regular pattern of going on diving trips, and I didn't have anyone else to go diving with. I didn't have anyone to go diving with, and so at some point I said, that looks like fun, can I come with you? So for the last couple of years I've been tagging along on their diving trips, and on, what day is it today? Sunday. On Friday afternoon, I picked up my gear. It was down. Stephen says, don't go diving in Canberra. No. On Friday evening, I picked up my gear. I had my tank. It was hydrostatically tested, and regulators were serviced, O-rings replaced, my BCD was serviced. So all of the O-rings and everything have all been replaced. It should all be in good shape. And I did that. My tank wasn't actually due for hydrostatic testing, but I did it because it was on a very bad cycle. Last time when I got it done, I took it in, when would it have been? September or October, I think it was, that I dropped it off. And for some reason, no, for an obvious reason, that was a really bad time of year to drop gear off for testing. And I didn't get it back for something like 2 months. I didn't get it back until late December. And that means that the 2-year test cycle on things like the tank fell into the good weather period, and that the certification would expire pretty much right when you want to start going diving, when the weather is nice at the end of the year and through January, that sort of period. So I decided to go early, and I had my gear tested, picked it all up. So at least this means, when is it now? It's May. So it means now that my gear is, if I follow the 2-year cycle on things like the hydrostatic testing, or regular testing of other gear, the cycle ends at the end of the dive season. It's in this sort of period where everything's gone cold, and before you would do things like trips to Queensland for winter diving. It's in that window. So, yeah, anyway, point being, I now have all of my gear back. The tank is sitting just over there. Regs and stuff are over there. Oh, one thing I've been wanting to do, I should have done it on this service, is reconfigure.
I tried dating a diode, but the love only went one direction.
Henrik, the love only went one direction. So it was from you to the diode, not back the other way. Either way, if it's one way, it's not good. Doesn't matter if it's incoming or outgoing. The love's got to go both ways. So where was I? Yeah, I want to switch to a long hose setup on my regs. So yeah, this is a squirrel like a chase. Okay, I'm going to give you. I will try to stick to the 2-minute version of this. The way back in the day, it was normal for divers to have. I'm backing up, trying to figure out how much of this to explain. All right, the regulators on scuba gear, there are 2 stages. There is the tank, which contains the pressurized gas that you're breathing. Typically just compressed air, but it might be like a nitrox mix or whatever, or a trimix, whatever the gas is that you're breathing, stored at high pressure. It then goes into the first stage regulator, which is the part that is on the top of the tank, and what that does is it reduces the pressure a bit. So the pressure is reduced in 2 stages. It's reduced in the first stage, so you then get pressure, like you then get air coming through down the hose that comes to the regulator that goes in your mouth, and that is what allows you to draw air in, etc. And Matt Westlake said, "Coming cave diving? Oh, I really want to one day because the idea terrifies me, so I want to do it." And so the first stage is responsible for reducing the pressure to a point where it is. Anyway, it doesn't matter that much. It reduces the pressure. Then there is a diaphragm inside the second stage, which is the thing that you stick in your mouth. Like, it's got the mouthpiece and everything on it. And the diaphragm and the water pressure kind of work with each other, so that when you stop breathing, it closes, no air comes out, and then when you suck on it, so you inhale, it opens the valve, and then you can receive air, and it does pressure compensation based on how deep you are. So, okay, none of that was relevant to the actual point. The point was, it used to be really common for divers to dive with just one regulator. And if there was a situation where you had an equipment failure or someone got into trouble, then you would buddy breathe, which is when you take a couple of breaths, you pass your regulator to your buddy, they take a couple of breaths, pass it back, so you alternate. And one of the exercises that you do as part of dive training is buddy breathing. And so essentially you're spending half your time holding your breath while you are, or just gently exhaling actually, while you are waiting for your buddy to take their breaths and then pass the regulator back to you. Now that is not a sustainable way to live. And the point is that is something you do when you are in, when something has gone seriously wrong with one of your sets of gear, and it is time to get out of there, get out of Dodge. But you get out of Dodge in a controlled, calm way. And then what happened was there was a period, like through I think it was in the 80s, when it became common for dive instructors to have extra regulators attached to their first stage. So they'd have the first stage and they'd have their own regulator, then they'd have like a spare regulator that they could use for other people to use. And then it very quickly became just a standard thing that everybody dives with 2 regulators. It's the way it is. I don't remember seeing anyone, if you were on a dive trip and someone had a single regulator set up, you would go, what the hell is wrong? So the deal now, so what's happening is that there's been this sort of sequence, an evolution in the equipment and in best practices. And it's at the point now where the standard practice / best practice is that you dive with 2 second stages. You have the one that you are breathing from, and you have a spare, which is typically clipped on somewhere, or it is tucked in a way that you can grab it out at short notice. So if your own first stage fails, you can just pull it out, grab your backup, stick it in, and deal with the situation. If you are diving with someone and they have a gear failure or you have a gear failure, then you can grab the spare and pass it to your buddy, and you hold on to each other so that you don't, rip regs out of each other's mouths and that sort of thing. And and then you make your careful ascent to get out of the situation. But at that point, you're not buddy breathing because both of you have a regulator in your mouth the whole time. You can just breathe normally. Now, what has been happening more recently? So the way that normally works is you have a short hose on the regulator that you're breathing, because it comes from the first stage just around, like comes around your head, comes into your mouth. I could go and grab mine and show you actually, but it's not that interesting. You understand what I'm saying. So you have a short hose that comes around, goes into your mouth, and then your backup regulator is on a long hose so that you can pass it to someone who is, obviously their face is further away. So you need a longer hose for them to be able to comfortably reach it and have it in their mouth. So what you do is, so the wisdom was, if your buddy has a problem, you grab your spare reg and you pass it to them. But what a lot of people are doing now is a setup where it's the other way around of thinking about it. It's almost like you are diving on your backup and your spare and your, it's not really a primary, but anyway. So the other way of doing it is you dive with the regulator with the long hose in your mouth, and you have the regulator on the short hose, which could be on like a necklace. So the regulator is hanging just on your chest somewhere in easy reach. And so you have the long hose on your main regulator, and if anything goes wrong, like if a buddy needs air, you're not messing around trying to find your spare. You just grab the one that's in your mouth, take it out and pass it to them. And then you grab your own backup, which is hanging around your chest, you put it in your mouth. And there are a few reasons for that. One is it's faster. If someone is in an equipment failure situation, they are seconds away from going into severe panic. You've got to deal with it as fast as you can. So, and it is much easier to grab the regulator out of your own mouth and pass it to them than to find your own backup, which is probably floating like down around your side. It's out of sight. You've got to feel for it. It might be, that sort of thing. It's just quicker. And then your own backup can be sitting right here under your chin, ready to then just grab, stick in your mouth, and you're good. So, my octopus setup is in the traditional setup at the moment, where my secondary reg is on the long hose, which I tuck into one of the straps of my BCD and have it in a place where I can pull it out if I need it. But I want to reconfigure the hoses so that I am running on the long hose primarily. Wagon Load says you can also Velcro the long hose to your chest. Yep. Yeah, there are all sorts of things you can do. Point being, I've had in my mind for a little while that I want to reconfigure my regulators so that I am primarily breathing off the long hose, not off the short hose. And that just means I'm going to have to, what it means is unscrewing the hoses, the low pressure hoses from the manifold that comes off the first stage and changing the ports, rearranging it. First stage ports. Let's see. I had no idea I was going to be talking about this. So yeah, there are all sorts of ports. Oh, this is a look at this. This actually looks a lot like mine. I've got a yellow hose on mine. So this is all the different hoses coming out of the manifold that's on the first stage. And here's a picture showing different things coming off it and different orientations. So what happens is that this manifold up the top here has low pressure and high pressure ports on it. And basically it's a cylinder with all of these little threaded holes going into the inner chamber. And so you
Soggy
can...
squirrels.
sorry, yeah, soggy squirrels. So you can screw hoses into these different ports, and they usually have a bunch of spare ports. And you can see here there is there's a little block off cap. It's basically a bolt with a gasket on it. So any ports that you're not using, you screw a little cap into it. And this manifold gives you flexibility that if you want to reconfigure your rig, you can unscrew low pressure hoses and just move them around so that the geometry is correct, because you want some hoses coming over your left shoulder, some hoses coming over your right shoulder, some, like, they go into different places. So what I need to do is pull hoses off the manifold and rearrange them so that my long hose is coming over my right shoulder, and have it rigged so that that goes to my primary second stage regulator. Yeah, so things to change. Yeah, so this is a diagram of the inside of the regulator with the different ports and things. Yeah, and there are spare ports because you can do things like attach a transmitter for a pressure sensor for your dive computer to be able to measure the pressure that's inside the tank. Yeah, oh, there's a good picture of one. You can see the yeah, you can see that this is like capped off. This is a DIN mount, not a yoke mount, which is different to mine, but still, same general principle. You can see that there are these blanking off covers here. There's another one up on the top. There's a hose in it here. But if you had another hose that you wanted to add to the low pressure ports on the first stage, you just undo one of these and you screw the hose into it. Anyway, anyway, why am I talking about that? I don't know. Don S is here. Okay, so a few more people have joined the chat. Matt Westlake, David Crisp, Austin. Welcome, Austin. Good to see you in the chat. Don S from NZ. Also, Gavin Jackson. Good morning. Is it going to event triggered say? Is it going to work? Event triggered. Let's see if this will work. Event triggered say. What does that mean? Generating audio.
I'd rather go flying than diving. Compared to waterborne, it's a faultless record. We've never left one up there yet.
Yeah, that's true. You haven't left one up there. Yeah, people tend to come back down again. What goes up must come down unless you achieve escape velocity. Yeah, so, yeah. David says, absolutely, if all goes wrong, you just have to stop doing what you're doing and wait to reach the ground. Yeah. What? Okay. Pebble. Can I recommend Little National Motel in Canberra if it suits Jono? Can recommend Little National Motel. Okay. No, accommodation is already booked. I don't even know where. I have been told where, but I was not paying attention at the time. Oh, no, I was paying attention, but I did not commit the specific location to memory because it was not important at the time. Yeah, okay, so things. I'm going to get back to this because this is cool. So where are we? Here, we are here. Quick subject change. I need a sound effect for a topic change. Whatever, like, you know, the chimes sound, or I don't know, an elevator sound. You are arriving at floor 3. Menswear, robots, and snacks. I don't know. Okay, so conveyor. Okay, conveyor. Bing. Yes. This is giving me grief. So let's do a brief conveyor something recap, update, frame. Now, this last Sunday, I showed you the mount with the
At
NEMA
Tinker 001 said, ID suggests the sound of a squirrel chattering.
The sound of a squirrel chattering. Yeah. Does it have a... Yep, it does. Okay. So this is... Oh, the position is wrong. I need to move that. Hang on. Why has my space mouse stopped working? Why? I've got to say... I don't know if this is a 3D Connections thing or a Fusion thing. I am inclined to say it's a Fusion thing because Fusion is so buggy and it is such a painful, frustrating tool to work with these days that it's probably a Fusion thing. Yeah, Space Mouse has stopped working again. I wonder if, oh, it might be because my computer rebooted. Menswear robots and squirrels, says John Whips. Yeah. Wagon Load says next project is a robotic diving buddy. Oh, Superhouse projects. Look down here. If we come into the S area, see squirrel. See that? That right there. This is a project that I started on a diving trip 2 years ago. In fact, I think it was after. No, it was after the dive trip. This was in Cairns, so I was hanging around in the hotel in Cairns after diving because we couldn't fly for 24 hours, and in fact, I might have even started it on. No, I didn't start it on the boat. Yeah. let's forget. I said that. Honey, I'm back. Hey, Vic. Wagon Light says, I have a wireless mouse and it stops every time the battery dies. Yeah. Yeah, this isn't the battery. There is a very poor interaction between the 3D Connection Space Mouse and Fusion. They have very annoying, where are we, preferences, interactions between each other. General, where is it? Somewhere in here. API. Am I showing? Oh, Fusion MCP server port. The design tokens, material graphics. Is it graphics? Somewhere in here. No, I don't think it's in graphics. It's in, there's got to be a controls thing here somewhere. There is some option for, should the space mouse, oh here we go, default orbit type, pan tilt types. No, that's not what I'm thinking of. Somewhere in here, there is a driver mode for the space mouse. There should be a search. There are so many preferences in here. Tokens. Yeah, I'm probably going to be doxing myself left, right, and center here. Somewhere in here, there is a setting for how it should. Now, if I click through all of these, I've got the best possible chance of doxing my account. There is a thing that controls. It's like a. Do we use the old style driver or the new style driver for the space mouse? Let's see. 3D connection helper. Let's do this. Launching. Yeah, there are all these DIY 3D mice projects around. There are so many of them now. Try FreeCAD noises, says Vic. No, Vic. This is one area where you are wrong. So wrong. FreeCAD, no. I've tried. I don't hate myself that much. Come on, why? 3D connection, helper. What about 3D connection home? Okay, not trainer, viewer. Okay, let's see if this works. This is the 3D connection viewer. Oh look, the Space Mouse works. It works fine. The OS knows about it, but Fusion, no, not doing it. So annoying. It just breaks frequently. And then, I don't know, I've got to update Fusion again, or reinstall the Space Mouse driver, or reset permissions. Half the time that I want to use it, it's just broken. So, what am I doing? NEMA 8 stepper, can I move it, or is it going to... See, it's... create copies. No, I just want to move the component. Maybe rigidly assemble to the default component. Okay, what if I do... Can I do a view... Display settings? Can I show joints? Object visibility. Joints are visible. So there's no joint.
Time to UN fuse.
Yeah. So there's no joint. There's nothing locking those together. Fusion, why are you being stupid and not allowing me to move an object? Why can't I move this? Oh, it says that it's chained. That's just because it's a reference to an external thing. But I should be able to move it. Anyway, I'm getting off topic here. I'm getting into my usual...
underscore creations said, can't move because it is a linked component.
Yeah, it's linked, but why can't you move it? What does being linked have to do with it? And sometimes you can and sometimes you can't move linked components. It's referencing out of another file. It's just been inserted. But yeah, you can't move it. You can only copy it. Why can't I move it? I should be able to have linked components located physically anywhere within this assembly. I should be able to joint them onto specific vertices. I should be able, yeah. Anyway, okay, so this is the thing where you can help me solve a problem, because the NEMA 11s are weak. They stall. Like, you can stall it and it won't even start spinning again by itself. That's how weak it is. There is something seriously wrong. Now, I've got the NEMA 8 mount. I've got, because it gets its origin from that link. You'd break many files if you move things. Only way to move it would be when first placing it within the file. Yeah, but I'm not trying to move the object within its origin file. I'm only moving its placement within the assembly. And an assembly should be able to move any child objects around to anywhere. That's the whole point. If they're all based on their original origin, it means that you have to change the origin in the original source file if you want to change it in the assembly, which means assemblies are useless. So anyway, this is the NEMA 8 mount. This is the NEMA 11 mount, which, being bigger, does not have a shell that wraps around the stepper. So I will give you now a brief demonstration of what happens when I connect these up. Where is that? Where is that? Okay, I'm going to grab out the motion controller. I'm going to switch to overhead view there and grab out the motion controller. That I got for playing around. Look, more NEMA 11 steppers are there. Benchy on Benchy is there. So here we have a NEMA 8 stepper. here we have a NEMA 11 stepper. You can see the difference in size there. Another NEMA 8, another 11. So I've got 2 of each. I'm going to put 2 of those away and just have, oh, in fact, I'm going to put that one away, keep this one out just because it's neater. I revised the print to make it neater. This is the better version of the bracket. There is that. I've got a bunch more NEMA 8s here. And here I have the Tiny G. I've got these steppers hooked up for the RepRap Micron. And I'm going to add power to that. I'm going to hook up some steppers and I'm going to show you what happens, which is not what I want to happen. And it's probably because I am screwing it up, and you can point out how I'm screwing it up, and then it can be fixed, and we can all be happy. All be happy together. Plug in USB. I've got to plug USB in at the other end. Get myself a what do I need? Power supply is currently set to 25 volts. Let's change that. I'm going to make that 12 volts, and the current limit 5 amps will do. I deliberately want the current limit to be high because I want to apply the current limit using the motion controller. All right, I'll turn on power. Oh no, before I turn on power, let's hook a stepper up. So these have got a little bit munged because they've been put in and taken out. I made up this little adapter so that I could just plug the NEMA 8 steppers in. And because they've got these JSTXH connectors on them. Oh, come on, line up, line up, line up. Yes, maybe. Yes, got them all in. Okay, while I am messing around with this and unable to see the chat, people start thinking of nerd brags. All right, so just make sure that that little strand is not touching anything. It's not. Okay, NEMA 8 stepper. Here we go. I'm going to plug the NEMA 8 in. I'm going to turn on power. And then we've got to get ourselves, I'm going to stick a glob of blue tack on that so you can see it. And get ourselves over here and cool term it so that we can send a command. What do I want? Options. I want that serial port at 115200, terminal, line mode, and connect. And then, let's see, we've got bodoink. Yep, that's good. So now I should be able to do something like G0. This is going to drive the motor at, this is a rapid, like a G0 is a rapid movement, so it's going to go, it doesn't need a feed rate. It's the A axis, and let's move it to 20. So, switch back to overhead, I'm going to hit enter. Oh look, you can see it spin. Yay! Now what have I got it set to? I've got the current limit on that particular channel is sort of in the middle. In fact, I'm going to set it in the middle. And I can see on the power supply how much power the motor is pulling. Now, if I give it a little bit of a longer go, I'm going to send it to a position of 100 this time. Hit go. You can see it spinning. And I can stall it quite easily. Even just touching the end of the blue tack is enough to stall it, and it was skipping steps. Now that was pulling, I think, about 1.5 amps. If I turn this up to there, so I've increased the current limit, and I'm going to send it back. I'll spin it back the other way. I'm going to send it to position 0, and we'll see what happens now. Now it spins. I can still stop it, but it takes more effort. It's actually doing a lot better job. And the motor starts to get warm, like noticeably warm. If this was running continuously, and I've done this in testing, I'm gonna do this. I'm gonna stick this up to, I'm gonna make it run for a longer time. All right, it's running for a longer time, which means it's gonna have, so it's currently pulling 2.7 amps into this, and I could turn this up. In fact, I'm going to turn it up. That is now still 2.7 amps, but it's getting noticeably hot. The torque is okay, but it's not great. So this, I think, would just do in terms of the torque required to make the conveyor move. But it is now getting really noticeably hot at 2.6 amps into this little NEMA 8 sitting inside this 3D printed enclosure. So it's only, the metal is exposed on the back. If this kept going for a whole lot longer, it's going to stop soon. It must. What's its position? Pause. Yeah, this, does it still stall if you run it slower? Yeah, yes, it does. 2.6. Yeah, I'm gonna hit stop. I'm gonna reset this. So because it is getting painfully hot, and the torque really just is not quite there. So the conclusion I'm coming to is that a NEMA 8 maybe, but probably not. So you would think logically, no problem. NEMA 11. Next size up, more torque, etc. This should solve the problem. But no. So let's verify that. I'm going to take this out. What I should have done is put an XH connector onto the NEMA 11 so I could just plug it in. But then that would prevent me from doing a couple of the things that I am just about to do, including switching coils around. Now, I need people who know more about steppers than I do to help me through this, because I think I have a problem with my wiring, and I think that...
At Grant Meisel said, longer motor see above.
Longer motor. Yes, you can get something like a NEMA 8, which is the same face profile, but with a longer body, and it has more torque. Yep. And also what I could do is make it exposed. I could remove the sides of this so the metal is all exposed so that it can radiate better, like this one. So this one would dissipate its heat a lot better. But for now, I should have done it with the other. I should have done it with this one because it's got the... Can I get this off? Maybe? Maybe? Don't want to damage my Weeha screwdriver. Okay, I'm going to put this drive gear onto it. So, alright. So this is now set up with the drive gear on it. And the colors, according to red, blue, green, black, white, these were some notes to myself from previously. The end result is, if I follow the, now the way the color codes work on this, coming out of the back of this motor, it is...
Cooling fans controllers.
Cooling fans controllers? The way the coil connections work is a A plus, B plus, A minus, B minus, I think is the order for the A and B coils. And so the blue, red, green, black is not the order that you connect them in. Red and blue, green. Interesting. That is swapped relative to that. What order they... Yeah, the order that they physically come out of the body of the stepper is often interleaved. So that's swapped there to there. Yeah, anyway, I'd have to pull up the documentation again now. So the end result was that one of the valid connections for this, and also you can reverse the direction of a stepper by swapping two wires. I'm going to follow the same color code that goes onto these other steppers. So these are the big NEMA 17s. In fact, what I can do is fire up one of those just for comparison purposes. And what I'm about to show you is that this NEMA 11 has no torque at all. And that's what makes me think that I've screwed up the wiring here. What do I want to do? Yeah, okay, let's do that. Connect. Now, if I do...
Do HHH. Build a water cooling loop for the steppers.
Okay, this is... I'm going to send it to... So this is with... The current is maxed out. So it's going to be delivering close to 3 amps. Or it could... It depends on the coil resistance, of course. But watch this. What you're going to see is that it is going to accelerate the stepper, and it stalls and then slows down, and then the stepper starts moving and then it stops. So this is without me even putting any load on it. You'll see that it doesn't behave properly. Look, it's stalled. It's sitting there stalled, and then as it approaches the end and it ramps down, then it starts spinning. So the stepper cannot spin fast enough. It does not have enough power to even move itself once the step rate is beyond a certain point. So that is usually indicative of miswiring. And I have tested this. So this is actually the first time that I have tested this stepper. I was doing it with this stepper previously, and I thought, maybe it's a dodgy stepper. I have measured the coil resistance on these, and I am pretty confident that I have it correct. So I'm going to check that. Vic says, is that really a 6-wire stepper? No, it's a 4-wire stepper.
Is that really a 6-wire stepper?
Grant says, from memory, they are independent coils, so if you put the wires in the wrong way, either nothing happens or they go backwards. So this is reading 6 and a bit ohms on one coil, 6 and a bit ohms on the other coil, and mega ohm, no connection between the coils. So that is definitely one coil, that is definitely the other coil, and they are connected to A1, A2, B1, B2. That should be correct. So if you swap, okay, here's a test. I'm going to squishify this, and I'm going to say, Simon says, it looks like your acceleration settings are too high. Yes, but it's not accelerating very fast. You can see how slowly this ramps up. I'm going to send it back to, I'm going to send it backwards to 50. All right, so it's going to spin in a certain direction. We've got to pay attention to the direction that it spins. All right, so it's spinning clockwise. Oh, and it actually kept up the whole time that time. Now, it was spinning clockwise. I'm going to swap two of these wires. I'm going to swap the black and green wire to reverse one of the coils, which, and we'll see if that makes any difference. I do not think that it will, but I'm just doing this for the sake of the exercise. So I'm now going to drive it in that same direction, but it spins the opposite direction. Okay, so we've swapped the wires on one coil, so now it goes in the other way. But does it have any more torque? Turn it off first, Simon. Oh yes, I should have done that. It's not powered up though. It's the Simon is correct that I should have turned it off before. The Tiny G is set in a mode where it isolates the stepper. So there's no power to this stepper right now. It is powered down when it is not in motion. Oh, when it's not in cycle. So it's in a not in cycle mode. Now, what was I doing? That's right, I'm just going to try touching it. Oh! I can stall it. And if it stalls, it does not start again by itself. Does the motor have the same response on a different stepper controller like a 298? I don't know, is the short answer. I don't know. Need a cuppa. Yep, Vic, I think that's a good idea. Back to there. Yeah, that feels like it's the weird thing is it feels like it's got a decent amount of torque until I stall it. And then when it stalls, it can't restart itself. That to me seems very, very strange. And I've tried it with different levels of microstepping. Like the config in here, I've turned off microstepping. I've set it to 8 microsteps. Yeah, anyway, I'm at a point now where I need to figure out what is going on with these steppers, because I think the NEMA 11 should do the job, but it is just doing this weird thing where if it stalls, it won't even restart itself until the speed gets down to a certain point. There we go. Maybe I need to drop...
@Austin_creations said, does the control chip have stall protection enabled?
Ah, stall protection? Stall protection enabled. I don't think so. What are these drivers? I'm not sure what the driver chips are on those. I don't think there is a config option for it. Motor 4. This is how it's currently configured. So it's on axis 3, which is A, step angle 1.8 degrees, 360 degrees per revolution. It's currently set to 4 microsteps. Direction is normal. Power management is in cycle, which is why it powers itself down when it's not moving. I think what I'm going to do is... does this controller have ability to detect stalls? I don't think it does. And if it did detect stalls, would it would stop then, surely? It would not continue to run. Or would it then keep running and attempt to... No, that doesn't explain it, because if it attempted to catch up on steps, it would keep stepping and failing. But what's happening is that it's getting to the point where it ramps down the speed at the end, and that's when the motor starts running again. Now, if I if I look at the settings on the A-axis, degrees per minute, maximum velocity, so it's an axis mode is a radius. Let's change the axis mode. Let's, I don't even know what modes there are, so let's have a look. 0 disabled. Okay, what is axis mode 1? Standard. Okay. Travel minimum, travel maximum, -1 degree. Velocity maximum degrees per minute. Jerk maximum. Jerk homing. Let's have a look at the settings on the x-axis for comparison. 500 millimeters a minute versus degrees per minute. So it still thinks, maybe I need to reboot it, because it still thinks that it's in a rotational axis mode when it should be in a linear axis mode. So, is there a save command or something? What about help? Show system. I don't think, does it need to be explicitly saved? I'm pretty sure it doesn't. I can just hit reset. All right, I'm going to hit reset, and we'll see if it then comes up, because that could be just a firmware bug. We will, yeah, okay. System ready. We'll see if axis A now comes up as a linear axis. No, velocity, it's still got degrees per minute, which is a rotational thingamajigamy. Now, what about standard? Can I do axis, what is axis mode 2? Axis mode 2? Oh, yeah. 2. Inhibited. Okay. And then 3 we discovered is radial. I wonder if there are any other axis modes. Like what's 4? Exceeds maximum value. Okay. And 3 is radius. Yeah, so 2 is inhibited. 1 is standard. So maybe I am screwing myself up here, because I am running this on driver channel 4, and I should change it to driver channel 3 or something. Let's do that. Yeah, minus degree jerk is in degrees per minute. Radius value. It's possible that channel 4 is only capable of being, surely not. Surely it is capable of being a linear axis, not just a rotational axis. It could be a limitation of the firmware on the tiny G. That is quite possible. Firmware build. What have we got? Hardware versions. Any other general settings here? M1 map to axis. Nope. Okay. I am going to. Oh, hello, Imi Amelia. Oh, Mr. Fixit says, what kind of RPM are you looking for? Well, this is part of my problem, is that I need everything from very, very super slow to relatively fast, because I have to, yeah, Grant says radial should be the same as standard, just different unit of measure conversions. Yes, that's right. Can it inject an anti-stall pulse instead of wagon loads? I don't know. Simon says you don't get feedback unless they are closed loop steppers. Yeah, in which case they become servos by definition, I think. Where are we? C-axis mode. A-axis mode, standard. Whereas B-axis mode, disabled. Okay. Let's have a look at Motor 1 settings and x-axis settings. So we've got all of that, and then I want to compare that to y-axis settings and see if they're the same. They should be. Yeah, okay. So what I'm going to do now is move this stepper to move this stepper to one of the other axes, and we're going to use the yellow one as a reference, which is the x-axis. I will turn this off now. I'm going to take out the y-axis stepper, which is one of the axis drivers for the RepRap Micron. So that is now out. That's the green one, is now out of the picture. And I'm going to transplant. Now in theory, as I think it was Grant said, it should make no difference because the radial and linear axes should work the same in terms of the way they treat the steppers. The only difference is the units of measure, like whether it's reporting that it's moving a certain number of degrees of rotation per minute versus millimeters of linear motion per minute. But one is just a conversion from the other. It's just a different way of conceptualizing the same fundamental thing when it comes to the stepper. The actual stepper is doing the same thing in both of those situations. It comes down to the mechanical linkage of what you're doing with the stepper. All right, so now we've got this stepper on the x-axis. This stepper is now on the y-axis motor driver. And I am going to, got to turn it back on. And I am going to change, I'm going to do, what am I going to do? G0, just for reference, I'm going to drive the x-axis stepper to 50. And then we're going to do the same thing with the y-axis stepper. So this is the x-axis stepper, and I'm going to just stick my fingers on it to test the torque. That is, oh, look at that, it stalled. And then it doesn't recover after a stall. Ooh, that's interesting. Yeah, that's the same behavior. I'm going to go up arrow, delete, delete, 0, enter. So it's working. It's a reasonable amount of, so it's 1.2 amps it was pulling. The current limit is actually lower than I was running previously on. Like this is turned to the maximum limit. Now it's midline. Okay, I'm going to midline this current limit and this current limit. So this compared to this. So now I'm going to do the same thing on the y-axis. I'm going to go Y50 on this one, and we'll see what happens. Yeah, see, it's stalled. Maybe it's just driving too fast, as someone said. That is not very fast, though. Not very fast. Simon said, read my earlier comment. Okay, Simon said, you don't get feedback unless you're closed loop steppers. Yeah, maybe it was prior to that. Once you stall it, you need to start the acceleration from 0 again, or it won't recover. Also, a higher voltage will improve high-speed performance. Okay. Wagon Loads asked, are the motors getting power from the USB? No, they're getting power from a lab power supply, which is coming in through that DC jack. That's suggested is the controller, because with basic stepper drivers I've used, they recover from a stall, says Grant. Okay, I am going to try turning down the speed. Let's go to, or I could do a feed rate, like I could do a G1F. Oh, actually, no, before I do that, what are the settings on motor 2. And on the y-axis. So y maximum velocity, 500 millimeters a minute. There is a conversion here. Where are we? It'll be steps. Here we go. Steps per revolution, step angle, etc. Oh, it's a 1.8 degree stepper. So that is... Oh, no. I changed this setting because they are 0.9 degree steppers. The NEMA 11, no, the NEMA 17 is a 0.9 degree stepper. Okay, but that's fine. That is not a problem. Search latch, none of that's relevant. Velocity maximum, I'm going to decrease the maximum velocity, which means that the G0, like the rapid speed, is going to decrease. Okay, let's try this. I'm going to do Y velocity maximum. I'm going to halve it. I'm going to set it to 250 millimeters a minute. And then we are going to do a G0, Y0, and watch what happens. It's moving more slowly now. Oh, and it's recovering from stalls. Look at that. If I stall it, it recovers. And it did feel like it had a decent amount of torque then. So, sure, maybe it was just driving it too fast. Maybe? Okay, I'm going to decrease the speed even more. I'm going to drop it to 150 and drive it for a while and see how warm it gets. So let's give this one a shot. So for a conveyor belt, that is probably a pretty rapid speed. That'd be on the upper limit of the speed that I would want it to run at. And, ooh, that is quite torquey. And it is recovering from stalls, effectively. All right, my faith has been restored to some extent. Now I want to try this again with the NEMA 8 and see with
if at first you don't succeed, try again at lower speed.
Yeah. Words to live by, Vic. Yeah, okay. I'm going to set this really slow now. And so with a velocity of 150, let's make it 20. And I'm going to drive it to, it's going to take a long time to get there, so I'm just going to drive it back to 80, the position of 80 is what I mean. Okay, so that is now turning at a reasonable conveyor belt speed. And I can make it skip, but it takes a bit of grip on it, like on this little toothed wheel, the drive gear essentially. I think that would be torquey enough for what I want. It's currently pulling 1.6 amps. It's getting warm now that it's been running for a little bit, but not crazy warm. I'd need to run it for a while to let the temperature stabilize and see how hot it gets. And let's yeah, these other steppers are now actually that's going to be screwing up my current measurements because I've got the other steppers connected. All right, I'm going to disconnect this stepper. I didn't even think of that. Because the other steppers are set to in cycle, they're not in motion power management. Therefore, it powers up the other steppers even when they are not being actively moved. It powers them up to lock them in position so that vibration doesn't make other parts of the machine move. I'm kind of being lazy and making things hard for myself simultaneously by trying to get all 4 of these wires into the screw terminal at the same time. One of them has not gone in properly, but the other ones I can screw down. Okay, and now I'll get this last one in. Maybe. Maybe. Okay, now this is the X, Y, Z axis. I'll just put the whole thing on. Z axis, I now want to reconfigure to be the same as Y axis. So, Y, oh. Power,
At
please.
Tinker001 said, every time I see you twist those wires, I want to yell tin the dang wires.
Tin the dang wires. Yeah, but you're not meant to tin wires that go into screw terminals. Not that it matters just for a quick bench test. You could use tinned wires into screw terminals, but they are a bad idea into screw terminals if they're going to stay in there. I really should put ferrules on them. Yeah, as Austin says, use a ferrule. I've got a pack of ferrules. Now, what am I doing? Oh, yeah, I was looking for the y-axis settings and then looking for the z-axis settings and seeing how they differ. I am going to go Z. What am I changing? VM. I'm going to change it to, I'll change it to 150. I'm not going to go down to the super slow 20. All right, 150. Then G0, Z.
At Tinker001 said, stranded wires directly in screw terminals are worse than tinned wires.
Maybe. Overhead camera, that's what I need. Okay, go. Now let's see if it recovers from a stall. It does. It definitely feels weaker, though, than the NEMA 11. I think as neat as they are, as nice as they are with these tiny little body, I think the NEMA 8 is just too weak to do the job. I think I'm going to have to go for the NEMA 11s. Let's set that to 20, which is what we were most recently running the NEMA 11 at, and then I'm going to go back to 0, which is going to run it for a while. It'll take a while to get there, just because it's so slow. Yeah, I can stall it quite easily. So it's currently pulling 1.7 amps, but that's with the other one, so that is splitting the power between the two. Current limit is currently set at the midpoint. So, and apples to apples comparison, same speed, same current limit. The NEMA 8 I can stall very easily at 20 millimeters per minute feed rate or velocity. The NEMA 11, which I will get running in a minute. Oh yeah, and I'm also just checking temperature on here. Where's my Zappity temperature sensor? It was here. I was using it just like on Friday or something. Where did I put it? Maybe it ended up in here. Oh no, I know where it is. I'm going for a walk away from the camera for a while. It is out in the mechanical area. I'm pretty sure it'll be here. Yes, here it is. On the mechanical workbench. So let's see. $40 on the body of the stepper. Just nicely warm. It just feels nicely warm. This one is currently in halt, like it's running current. This is actually a worst case scenario. 44 degrees. So this motor is currently powered up, it's energized, holding position, which means it's hard to turn the shaft. So that is maximum current through this motor right now. And it is, like it's warm. I can do this comfortably. So 44 degrees. $42. Cool down a bit because I stuck my hand on it probably. Okay, and this one has finally got to its destination. All right, so what have we learned from this? Firstly, that I don't have any idea what I'm doing. Secondly, NEMA 8s look cool, too weak. NEMA 11s are small enough to be acceptable and torquey enough. Next. The next lesson is what? I need to improve clearance along this edge. It's hard to see on camera, but this is very slightly wonky. If this was inserted into the frame, I'm going to exaggerate this, but the shaft of the motor is twisted like that because it's bonded on this end and it's interfering along this face, which is twisting the motor around. So I need to improve the clearance just like 1/4 of a millimeter or something on that face. I might give it 1/2 millimeter just to be on the safe side. And then it'll pull up flush against this face and it'll be perpendicular to the rail of the chassis. Okay. Other learning is don't run them too fast. So these will recover from a stall if I don't run them too fast. Out of curiosity, I am going to run one super slow. Just to see, because when I'm feeding into the reflow oven, this is actually the whole reason for going to steppers. I can make, with regular DC motors...
Assuming space along the axis is not an issue, you could get a longer NEMA 11.
Yeah, I could. I mean, ideally, I don't want the motor to protrude beyond the back of the frame for reasons I won't get into right now. It's related to how the geometry of the thing is set up, where the frame goes and what goes in front and behind, etc. But this is a compromise. We can deal with it. But I don't want to have a massively long stepper sticking out here. So I could get a NEMA 8 with a really long body would be an alternative. But I think just going with the NEMA 11s is probably a reasonable compromise. It means that the front profile is slightly bigger. It also means that the shaft, it's a little bit hard to see, but if I align, when these go into the frame, they butt up against this face right here. If I align that and that, right now they are at the same point, you can see that this shaft is further away from the edge of the frame than this shaft. The gap from there to there is smaller than the gap from there to there. And that is 2 millimeters more than the gap that I had when I was running one of the little N20 motors. And that has an effect, that offset has an effect on the length of the conveyor belt, or more precisely...
001 said, back to the idea of rollers with individual steppers. Then the 8S would have plenty of torque.
It would. In fact, I'd need smaller ones. So the But then these are like 15 bucks each, so by the time you have 30 or 40 of them in there, it's $1 million conveyor. I need to make the rail shorter to compensate for the fact that this is further out, because the conveyor belt is a fixed length and I need to move it. So that then has other flow-on effects with the design of the corner bracket that the frame goes into. So that is also a potential issue. So there are trade-offs all over the place here. This is all about engineering compromises. I want to have, ideally I want that shaft to be about 8 millimeters closer to this, but I just can't achieve it because of the body of the stepper here. It just is what it is. I've got to work with that. So I think this is the way to go. I think NEMA 11s are my answer there. Now, what next? What next indeed? Okay, I'm going to show you a little tale of woe. This is my RepRap Micron tale of woe. How am I going to do this? I'm going to unplug all of this, move this out of the way. It's a tale of woe, but it's not a tragedy. Last week at the barbecue. So the barbecue last week was huge. By far the biggest turnout we've ever had to the barbecue. There were so many people here.
Noises here.
Yeah, so this is the Pika, and last week this was sitting on a box. So this was after the stream finished. It was sitting on a box just to my left, off at the end of my workbench, and I was talking to someone and wanted to get something out of the box, and without really paying attention, I grabbed the corner of the box and just sort of lifted it to reach in, and when I did, this mechanism slid off the top of the stack of boxes and fell to the floor, and crack right there. Look at that. Broken flexure. So this whole structure is now a throwaway job because that is broken, and because this is a single piece 3D printed in one go, that can't be repaired. My Pika is dead. The Pika is dead. Long live the Pika. And this one, I just basically hit print on the printer again. And this is another one. It's not sliding very well because it's not sitting on the base, which means it's sitting directly on the bench. But I now have another Pika.
Recover the screws first.
Yeah. So yeah, there are nuts and things in this that I could try to recover. Some of them could be tricky to recover, but I'll try. Not that the nuts are worth anything much. So this is the Pika that has been on the stream a few times over the last few weeks, but it is dead, and this one is going to take its place. So I've actually started unscrewing. Oh, that's the wrong screwdriver. I want this one. Started unscrewing the base for this so I can remove it. Oh, that's loose. That one's loose. Are there any screws here that I haven't undone? Oh yes, these ones here. But I'm not going to put this Pika on its base yet, because being off the base is actually beneficial in some ways. It means that when it is sitting on the bench like this, the center structure is supported. It's sitting on the bench, and therefore it's not going to be damaged by pushing down on it. Like with this broken one, if I have it sitting on the bench, that center point is nicely supported now. So it's a lot safer than when it is sitting up on this. So what I think I'm going to do is proceed with more of the assembly on this one before I put it onto its base. And also, I'm going to try not to be an idiot this time and knock it over, which was a very sad state of affairs. But that is one of the nice things about 3D printing. You can just print another one. So, pick a 1, pick a 2. Yeah. Now, this afternoon I am going to go and see my daughter, so I'm not going to be hanging around on the stream for long. Like, I'm not going to run much overtime. And sorry, I'm trying to put screwdrivers away when there are USB cables everywhere getting in the way. So, a couple of things I wanted to talk about. One is, Tinker says, am I currently printing a backup just in case? Yeah, Pikachu. Oh,
John, are you currently printing a backup just in case?
Print holes for safety pins to lock it down to prevent breaking. Maybe. Vic says, idiot at this end is trying to rotate the view to see if you have the latest version. Yeah, I do that too. Like, try to rotate the view of a screen capture or something. It's like, no, it doesn't work like that. The latest version, I don't know. I may not. I think I did. Yeah. Tinker had a good suggestion for Vic, which was new entry for the documentation: do not drop. Grant says, no, you should not feel this, Grant. Grant said, I feel slightly responsible being the person you were talking to. I would have thought that it was stronger given you could not break one on the stream. Yeah, it must have just been, no, you are not responsible in any way, Grant. This is entirely on me. I should not have lifted the corner of the lid of the box while the picker was sitting on it. Okay, Vic says, I moved some of the nut holes to the side so you could insert them without gymnastics. Oh, okay. Ooh, Mr. Vixen says, got to run, have to go to the hardware store to get an M4 button head screw. I have M3s and M5s, but can't find any M4s. Later, Mr. Fix-It. John says, I'm now the proud owner of a Discovery Artisan 32 10-100 times digital microscope. Now, how to get the software from the CD to my iMac. Software on CD. Really, Mr. Discovery Artisan. Really. Shipping CDs in this day and age. Or, more to the point, well, yeah. It should just come up as a UVC device, which is not useful if you want to control attributes like exposure and all of that sort of stuff, but at least it would let you. Anyway, so a couple of things. Oh, in passing, this Fusion has been breaking my mind in relation to generating production files for this board. Okay, I'm going to show you something very annoying here. Conveyor. I have been trying to order these PCBs since Thursday or so. Now look at this. Conveyor 4.0 broken. Is this the one? I can't remember. I have got multiple copies of this project because somehow it has ended up in a state where it is broken. Is it opening? Yes. Oh yes, this one is definitely broken. And look at this, there's a typo in Fusion's UI. Inaccessible associated file found. Nice one, Fusion or Autodesk. Now this, okay, watch what happens now if we go into, I wonder if I can push to 3D PCB. It may break because of the inaccessible file. Yeah, it's just going to fail silently, like boom, failure, and there's no way to fix that. Fusion is broken in that respect. If I come back to, yeah, it's a file that was moved to the trash, can't be moved out of the trash, and the documentation that Fusion, like that, when it comes up with a message, it has documentation about how to move it out of the trash, and it refers to things that don't exist in Fusion, like its internal help is broken. You can tell I'm progressively more and more pissed off with Autodesk. Here we go. Okay, so this is, you can see it's got the version 3.0A. The A because I made a clone of the project trying to fix the breakage within Fusion. And what you can see here is there is no, if we go to the 3D version of this, you'll see that it fails to render a PCB. Look at this. Oh, and of course my Space Mouse is still broken. You can see the copper. You can't see silkscreen. You can't see the PCB. There's no solder mask. So it's broken in terms of how it's pushed the its board stack up into the 3D view. So I'm going to close out of that. The way I got around that is I created a whole new project, brand new, and then I linked to the schematic and the PCB, cloned them. Then in here, I created a whole new mechanical layer. So if I come, like, look at this, M1 dimension. This is a line, it's a continuous line on the dimension layer, and you can see that the polygon honors the dimension layer. And then if we go to the 3D view, here, now it's working. Look at this. This is the version that has, you can see the PCB is there. You can see the silkscreen is there. This is what the other one should have looked like, approximately. Okay. Oh, made in Australia. That needs to come off. Because JLC will refuse to make this PCB. Yeah, so you can see this looks like a valid thing. I sent the production files to JLC. JLC, it failed on their data checks because they said there is no mechanical outline in the Gerbers. Hang on, let's come back to 40A. This is the, yeah, this is the one that I've got open. So 40A, new mechanical outline. It is fully, yeah. When I generate the Gerbers, according to, I wonder if the preview shows it. JLC, I'm just logging in off screen so that I can go to the specific thing and not reveal anything that I should not reveal. All right, replace file. Okay, look at this. Just look at this. It failed for a couple of reasons. First, this one failed because, oh no, not that. This one failed because it contains the word, so this is the one that they rejected. I uploaded these board files and they rejected it because it said made in Australia on it. So you can no longer order PCBs from China, at least from JLC and I suspect the other major board companies, that say made in Australia on the PCB, because it then becomes an export issue. So they cannot export PCBs from China that say made in Australia, even though the product is made in Australia. So anyway, they pulled me up on that one. Kind of fair enough. So they rejected the design on that basis. I then modified it, and if we spin it over here, oh no, not that one, 4.0, where is the 4.0? Oh. Am I looking at the wrong thing here? 4.0, there. I'm going to close these, just get them out of the way. Don't save. Is it this one? 4.0? No, 4.0A? Which one of these? I think it must be this one. No. Yeah, because it's got super confusing because the board file names are... Oh, no, Fusion, don't go into this stupid tiled mode. Fusion, I hate you. Now I've got to quit it in order to reopen it in order to get it into the mode where it shows the tree of stuff on the left. Alright, quit Fusion. Oh, Paul says, are you allowed design in? Yes. Yes. So I redid it. In fact, let's just have a look in here. So this one got rejected. Okay, so I modified the silkscreen and re-uploaded it to this. And then it got rejected because there is no board outline, which is the mechanical. Now let's check this out. If we go to the board viewer, come on, load, load, load. Maybe it's freaking out. Oh, unable, okay, it's unable to generate it because it probably doesn't have an outline. I wonder if this one is going to load in the preview. Maybe this one will fail as well. No, it worked. Okay, so this one, if I look at the bottom of the board, you see how it says made in Australia. But look, the board has an outline. All I did was I changed this text. I regenerated the production files, and now Fusion, for some reason, has not included an outline in the production files. I just feel like I'm spending so much time fighting this tool, trying to make it just work, do fundamental things. It just keeps breaking in different ways. The process is broken. Yes, you are watching me. Yeah. Stephen said, designed and assembled in Australia. Yes, that is exactly the text that I had in it. So I changed it. The replacement file, where the outline, the mechanical layer failed, I changed the text to say designed and assembled in Australia instead of made in Australia, which I think gets around their legal requirements. But then, yeah, I've just got to put some time into that. So now, this. So, turns out that Princess Fiona is a huge fan of the Pebble, the original Pebble watches. She has a probably a world-class collection of pebbles. Many thereof. So there was one point where she bought 3 identical ones just to have them. After going through several, and then when the day the API died was a very, very sad day, and she's been living without pebbles for years now. And now the Pebble Time 2 and the Round 2 have come out. So the old Pebble, the Pebble 2 Duo is the do-over of the old black and white watch, and then the new ones are color screens. And yeah, as Princess Fiona said, by accident, not by design, they're just a good tool. Yes, a very good tool. And so there was much rejoicing throughout the land when the new, like the RepPebble stuff was launched, when Eric, I think it is, came back with the new Pebble range, the Pebble 2 series. So this is the replacement for the original Pebble. And I have one of these on order, which should be shipping soon, actually, like in a matter of weeks. And this is the thing. This is such, this is a cool idea. What is it? What is going on here? Now, some of you may remember that for a while, while I was wearing a Fitbit, and while before Amazon broke their API for Node-RED, like they made API changes and changes to the way their authentication works on their API. They moved to a new generation of API and they deprecated the old one, and then eventually they turned the old one off. When that happened, the Node-RED integration for Alexa died. And up until that point, so I had the Alexa app running on my Fitbit smartwatch, so which has a microphone and stuff in it, so I could talk to my watch as if I was talking to Alexa. And you don't need a wake word. Well, you press a button because it's not listening unless you press the button. So what would happen is Stephen says, did the princess work for a coloured hat company doing documentation? No. No. The princess is a hardcore techie of the techiest of techies. So, so what I would do, it was really common. The way I controlled stuff around the lab here was by talking to my watch. What I would do is go turn on the air compressor. Yeah, that sort of thing. Turn on the oscilloscope. It was just voice control of everything around the thing by pressing the button on my Fitbit and talking to it, which was super convenient because it was a voice assistant that was traveling with me wherever I happened to be, and I could invoke it just by talking into my watch. Pretty cool. Now, what this thing does is kind of similar. It's like, okay, so right now I am wearing the Ring-Con smart ring, which is doing heart rate and blood oxygen and movement tracking and that sort of thing. So this is like a fitness smart ring, like a Fitbit in a ring. Maybe if I do that, you'd be able to see it better. So that is the Ring-Con. And right now what I'm wearing is a 3D printed version as like a fit test of this. What this little device is a button and a microphone and a transmitter. And that is it. It links to an app on your phone or, yeah, so it supports either Android or iOS. There are limitations in the iOS version because of the security model that Apple uses, but their goal is to support both of them equally if they can figure out a way to do it. And so the Index is like a little Dick Tracy microphone thing that you wear on your finger, and the top of it is a button. You press the button, you talk to it, you let go of the button, and that whatever you say to it gets sent wirelessly to the app that is running on your associated device. And then it can be whatever you want. So the use case that they have here is things like adding to a shopping list. Now, there are some really interesting connotations of this. So this is you can see a better view of it here. Boink. Silver, let's see, black, gold, oh, there's the collection. So you can see there's a little hole on there, which is where the microphone is. There is a button on the top. And the idea with this is that this does not have a rechargeable battery in it. The idea is the battery lasts a lifetime, the lifetime of the device. And it's supposed to be in the order of years of life. So it's not a thing that you have to take off every night and put on a charging stand and then put back on the next day. It is what it is. So never needs charging, privacy by design, no paid subscription, customizable and open source. The first use case they talk about is adding things to a shopping list. If your default behavior is to add whatever you say to a list, then you could just, when it pops into your head, you just go carrots, and it adds carrots to your shopping list. And then when you pull the associated app up on your phone, you've got the list of all the things that you've added to your list. But it could be all sorts of other things. Because this is truly open source, not pseudo open source, you can take the captured speech and do what you like with it. You could redirect it to something else. So what I've got in mind is using this to recreate effectively what I was doing previously with Alexa and the Fitbit. I want to be able to control everything around the office by speaking to it with the Ring. And because if it's in this position, so where this is sitting right now, there's a sizing kit. Basically, if you're going to get this, you need to order the correct size of ring. So there's a sizing kit, you 3D print it, and then you can try the different rings on and see which one fits your hand. And with this sort of thing, because your fingers will get bigger and smaller throughout the day as you become more or less hydrated, and you might think that your fingers stay the same size. They do not. You really need to be comfortable with it. So the idea is that you 3D print the test, you put it on, you wear it for a while, not just put it on and go, oh yeah, that's good enough. But you wear it for a while and be sure of the size, and then you order that size. So you can see that I've got this oriented with the button just there, which means I could, and the microphone would be just under there, which means that I could control things just by going, turn on the air compressor. So I could do that at any point, which would be great. And also for other applications, like if you were working with, I'm not sure if I should even bring this up, but say you were working with machine learning agents with a voice interface, you could talk to them through this and give them instructions. So that's the Pebble Index 01. Very interesting idea. So if you're out on a bike ride or whatever you're doing, you can just talk to your Ring and do stuff. And for what it is, it's actually surprisingly cheap. This is US dollars. and then there's a little bit of shipping on that. But for a smart ring with a built-in microphone that links to your devices and lets you do voice stuff, that is a pretty respectable price. Yes, I want one. I definitely want one. Vic says, that looks handy for a things to do stack. Yeah. And also, however, one of those would not survive on my trigger finger. Yeah. Dodgy. I'm not even going to reference that. Yes. So in the chat, there's an ongoing conversation. Princess Fiona said, wanted to surprise me with it as a surprise present, but was too excited and had to go on and on about it. And now I'm excited about it too. Yeah, so there are a couple of these currently on order. I'm excited. It's going to be fun messing around with the software for these and integrating them. And also the new Pebbles are are on order. So these are coming and these are coming. It's going to be good times. What else was I going to do? There was another topic that I wanted to talk about on the stream today. I don't remember. I do not remember. I have not done any RepRap stuff. I knew that this was going to be a totally random stream. Beetlebot, that's it. Thank you, Princess Fiona. I was going to do some Beetlebot stuff. That was the third topic. I'm not actually actively going to do any Beetlebot stuff now that it's 11:57, but I am going to... I could do one little thing. I have a problem with Beetlebot, and the problem is the USB to serial converter, because... let me pull up LCSC. The USB to serial converter that I was going to use for this is, let's see, cart, where is my cart? My shopping cart. Okay, that is opening. Beetlebot, Beetlebot. I'll open that while I'm pulling up. Is that it? Yeah. While I am pulling up LCSC. Where is my cart? Okay. Main shopping cart? No, I want to switch to a different shopping cart.
Quickly design a Steve or Steph-sized passenger seat for the Beetlebot.
Oh, that's an interesting idea. Main shopping cart. All right, I'm going to switch to held for future orders. I got a secondary cart. And now, this may all be a moot point if now we come in here and see that there is stock. Where is it? Where did it go? Here we go. Back ordered. Yeah, this thing. So the CH340K, the little USB to serial converter. One of the things I wanted to do with Beetlebot is use it as an experiment to try out the CH340K, which I have never used before. I have used various other CH340 variants. The 340G is the classic one. I actually have stock of the 340G, but it is a slightly annoying chip. So I wanted to try the 340K, and it is out of stock. Yeah. So I currently have it in the design. If we come to here, whoops, there is the 340K. I've included it in the design, but I can't buy it. Makes me sad. Where is this? Okay, so we've got, what I have done is we've got the USB hub in here. So we've got a single USB port, which is the upstream port. And that is located down here on the rump of the bot. So there's going to be a single USB-C connector on there that you can plug into, which will give access to all of the devices on the bot, including the S3 motion control processor, the ESP32 cam processor, and potentially other things like a third USB port that could go to another peripheral device on the bot. And that connection comes in from USB-C, goes into the USB hub chip, which is the TUSB 2036 that I've used before. We know that one, we know it and trust it. It's a good thing. And then...
At Tinker001 said, okay, who was watching the stream when they came up and bought up the supply?
Yeah, fess up, who did it? So we've got the 3 ports coming off this internal USB hub. We've got the first port going to the motion MCU, second port ESP32 cam, third port to the payload or other additional sensor. So we've got DP1, DM1, so data positive, data plus, data minus, I suppose you would say it is. DP1, DM1 coming to this. In fact, what I could do, while I'm here, let's actually do something. Let's make this one DP1, and we'll make this DM1. So we will tie that signal to the output of port 1 of the USB hub, port 0 being the upstream port. So the ESP32 S3, which is going to be the motion control. You can see it doesn't even have any of the H bridges or anything connected to it yet. I've got to do pin assignments on that. But the module is there. It's got power. It's got no reset control or anything, but it has the data coming from the USB hub. So when you plug into that USB port, you will get multiple devices coming up on your computer. You'll get a port for the S3, you'll get a port for the ESP32 cam, and you'll get a port for whatever else you've got connected onto port 3. So, CH340K. Okay, so that's DP1. Let's set, so USB plus. So this will be DP2 plus 2. Yes, and DM2. So I'm going to set this on port 2 of the USB hub. So that is the CH340K USB to serial converter. And there was a question there about RTS. Watching the video to Gogo Gomez. What did I miss? Somewhere.
Sure, you don't need to flip those.
Stephen said, does the K have the pins to do RTS, DTR for ESP? I thought only the higher pin count ones did. It does. So this is why it is a 10-pin package. So the 340G is the maxi package that's got everything. It's got all of the flow control pins, etc. There is a very small one, the 340, I can't remember what it is, like 340H or something, which is really nice. It's a little 8-pin package, but it doesn't have any flow control, so that's no good. The 340K is the smallest of the CH series that has the flow control necessary for hardware reset of the target. It's got DTR and RTS coming off here. It's also got CTS, which we're not using. So data terminal ready, etc. So we've got the funky donkey crossover double MOSFET trick happening here, where we are taking DTR and RTS and we are driving those 2 transistors which go to the IO0 for the boot mode and RST for reset, going, and this is the socket where the ESP32 cam plugs in. Yeah, so the CH340K should take care of all of that. It doesn't need an external crystal. It looks like the ideal chip for the job. Super cheap. Problem is, can I buy them? Can't buy them, which is very sad. So okay, I am desperate. I'm actually going to do this. CH340G, and let's see what we can find on here. 340G module, no, 340, what am I doing? It's not 340G, it's the 340K. 340K. Someone sell me a 340K. Does anyone have them in stock? 340, yeah, maybe. Let's see. Do they have, no, not that. I want 340K. ESSOP10, that, how many do you get in the pack? Is that $3.17 for one of them? Or is it like a 10 pack or a 5 pack? Surely that is not one for $3 something. Although, when you're desperate, let's see, this one was for 5 to something. Okay, so this is 340K, SOP10. Yeah, so SOP, I think that's what I need. What package? I'm pretty sure it was SOP10. ESSOP10. No, which is... I can change the footprint. If the footprint on this is not quite the same, that's okay. 5 pieces for $3.26, 20 pieces for $11.79. What's shipping? $7.37. Okay, so that gets me 20 for 20 bucks. So it's $1 a piece. It's not a disaster. I am GetLink. I am going to give myself some commission on this. I'm going to order them and whoop. Got to get into my, got to log into my parts acquisition spreadsheet. Oh, come on. You have been signed out. I just signed in. Google's account management doesn't like the fact that I have about 14 Google accounts. Actually, here we go. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I've got 13 Google accounts saved in this browser at least. There are probably more. Where are... That one. Okay, I want that one. Yeah, so every now and then it gets out of whack. It doesn't like it. Okay, here we go. I think we are in business now. Back to my parts orders spreadsheet. So I'm going to order that. What's the date today? 24th of May. And I'm going to order, I think it was 20 of them, wasn't it? CH340K USB to serial converter. And let's do the thing. I'm going to, just to make sure, I'm going to load the discount link. 20 pieces. 1, yeah, add to cart. Did it happen? Did it happen? I think it did. Go to cart. Why is it saying 28? There must be something else that is... Oh, look, I've got a couple of smartwatches Oh, there's an RP2040 smartwatch, ESP32S3 smartwatch. Oh, just got them sitting in the cart. Oh, mini. No, I'm going to turn that off. I don't want that stepper motor. I just want this. Yeah. $19-ish. Okay. Now I need that back here. What is the total price? What is the price? It is 2130 divided by 20. GST is 194. Cost of goods sold, 0. This is all R&D. That will do. And pay. All right, what I thought I was going to do was design out the 340K and switch to something like a CP2102N. So I'm just closing all those windows. Which is, because at least that way, it's a known part. I've got it here in stock. I use it on other projects, but I'm really wanting to use this as an experiment, like as an excuse to try this as a USB to serial converter chip, because I've never used a 340K before. I want to validate whether it is a reasonable part to use, just for future reference. And the reason is that the CP2102N, when you whack it down on a board, it does not have a default profile loaded. You have to run up the Simplicity Studio software, connect to the device, tell it what its USB PID and VID are, and set the port mode. You got to set push-pull pins for like RTS, etc. for reset control. You've got to configure its board, like its acceptable board rates, configure its acceptable current request, and so all of that I have saved as a profile. So I've got a default profile in Simplicity Studio, which means that I can plug in a device with a new CP2102N on it and just hit flash, and it sets all the fuses and sets the profile correctly. But you have to do that for every single board. So if you make a bunch of boards with CP2102s on them, you've got to connect every single one of them with Simplicity Studio loaded and set and configure the USB to serial chips before you can even talk to the microcontroller that the serial converter chip is sitting in front of. It's just an extra, it gives you more flexibility, like lots and lots of flexibility, because you can use your own USB vendor ID and you can customize the way the I/O pins work. It's a really nice chip. It does a lot of stuff. It's really quite powerful for a USB to serial converter chip. But there is no out-of-the-box default behavior that you can just put it on a board and then have it work. You've got to do that you've got to set it up regardless every single time. So what I'm looking for is a USB to serial converter chip that I can just place on the board, reflow it, and it works. No questions asked. It just comes up with the default USB, vendor ID, etc. and
At Tinker001 said, and not everyone building Beetlebots from your design is ready for this faff.
That is a very good point. As Tinker said, not everyone building Beetlebots from your design is ready for this faff. Yeah, so if someone else wants to build one of these, they should not have to mess around with it. It is a whole side quest to install Simplicity Studio. Then you've got to install support for, because Simplicity Studio, it's like installing VS Code or something. You're installing this big platform which supports a whole lot of different target devices and different software development environments. And so you install this big platform, then you have to install the plugins, like the support for the particular target boards. It's an exercise. It just it should not be necessary for a basic USB to serial converter. So now that is, yeah. That's why I want to do this. Yeah, neat little $1 or 40 cents or whatever, depending on quantity, USB to serial converter that you just stick it on the board, plug it in, and it does its thing. Yes. Vic says, do you have room for a set of alternative chip pads? Possibly
Do you have room
not.
for a set of alternative chip pads?
Create different profiles so each defines what the device is, like a robot arm. Ooh, that's an interesting idea. That is an interesting idea. But no, I probably do not have room for a separate set of pads. In fact, I don't actually know how I'm going to fit everything into the space that I have on this robot. Because if we come across and look at the assembly with the 3D printed structure around it, I have only a very small part of the PCB. So this PCB that you can see here, that is the overall outline of the PCB. Only a small part of it. Oh look, my Space Mouse has decided to work now. Fusion is now recognizing it, probably because it was quit and then reopened, and now it works. What changed? Who knows? Sometimes it works, sometimes it doesn't. Right now it is working. Okay, so what you can see there in this approximately square shape is, that is the room that I have for all of the electronics. So all of this stuff over here has to go into that cavity there. That USB socket. Oh, this is out of date. The USB socket should be there. Yeah, let's pull from this. There are more parts now to go on. We'll update the model. There we go. Now it's moved around. So now the USB socket is mounted just here. And as you can see, I need to modify the plastic to create a cavity to fit over the top of that socket. So what I've got is the H-bridge motor drivers in these cavities near the back of the motors. And part of the reason I put them here is to free up more space in here. So I've got this area where the white outline goes around. Everything has to fit into that. So that is the S3 module there sitting in the middle. I've got a bit of room underneath the ESP32 cam. So some parts will probably go there, like into that gap under there. So I need to bring the USB data lines from the socket, bring them up the board into here somewhere to the USB to serial converter, and no, sorry, into the USB hub, and then from the hub into the serial converter, and from there into the ESP32 cam. And then all of the power management stuff, that is the big problem. I've got to make all of this power management fit into this space. So it is possible, actually I could put some under here. There is a cavity here. Maybe that's where I could put the filter caps for the power supply. Oh, but there's a tab that sticks off the end. Oh, but then I could take that further around and make more room. Ooh, I could put a filter cap in each side in here. Yeah, getting this to fit is going to be a challenge. And I don't want to put it on anything on the bottom of the PCB because I want that to be a smooth surface so it doesn't snag on things. A bunch of little vertical subboards. Yeah.
Bunch of little vertical subboards.
What have we got here? That's the USB hub, I believe. Yeah, so I'm just going to grab this and move it. Where is... Oh, do I have the silkscreen layer turned off? Where is T-Silk? Oh, T, please. No, it's turned on. Oh, maybe I just need to... Yeah, there we go. Just rip up the polygon. So I'm going to grab all of this. This is all the stuff associated with the USB hub.
Are there any thermal constraints that might struggle with crowding?
A little, yes. Sorry, the box asked, are there any thermal constraints? The motor drivers may get warm, but not excessively so. Maybe I should spin the... I could put that right there. Now, traces can come out past those white borders, but components can't, because the plastic it'll knock plastic. So what I could do is put that there. I could rotate the S3 module, put it here, put it about here somewhere. Is it a mini? I hope it's a mini. Is it an S3 mini? Yes, it is. Okay, so that's an S3 mini. Oh, of course it is. It's got the row of pads under the antenna end, the ground pads. So then, what else do I need to fit? Okay, all of the voltage regulator stuff. Oh, made in Australia. That's going to make them angry. Deus Ex'd in Australia. Designed in Australia. I've got to remember to do that now on designs. As I go through designs and come across that sort of note, I've got to change it. 20 of the 6. What else fits into that square? Not a whole lot. In fact, maybe I need to put the S3 directly under the square. Under the... The problem is I'm going to have 2 Wi-Fi antennas in very close proximity. And this one is in a position where it's on the inside of the PCB. And the range is not going to be good on this. What I really should do is pull back the PCB around the antenna section here. So, oh, and this fuse. What should I do about that fuse? I've been thinking that...
Tinker001 said, wonder if they'd allow Made on Earth.
Yeah, I don't know. Made on Earth. Let's take this fuse. I don't think it's going to fit in there, in that area. Fuse. Maybe I don't even need a fuse. No, but I do need a fuse. The thing is, it's running off a LiPo battery. I kind of need to fuse the output of the battery, because if it is shorted, it's really bad. What I could do, Austin says, sounds like an excuse to buy a UV printer. Yeah, SMD polyfuse.
At Austin_creations said, sounds like an excuse to buy a UV printer. Can you add small SMD polyfuse?
Yeah, that's what I'm thinking. Not necessarily a polyfuse. I think what I could do
Externalize the fuse for easy replacement.
Yeah, that was my plan, was to mount the fuse on the edge of the body somewhere. And if the fuse blows, that is bad. Omniblock. Let's stick one of these ones down. I'm just going to throw it on there, not even in the circuit yet, just to see it. So this is one of the little surface mount fuses that Austin put me onto, and they are very, very nice. I'm going to throw it in. It needs to be in a place where you can get something like a pair of pliers in, or your fingers in. So I'm just going to throw it there for now. And then, let's just save it, since I can. Save. Notch under the fuse for the 3D print between the battery area and the circuit area. Notch for the fuse between the battery and the circuit area. Maybe. Yeah. So keep in mind that there is going to be a cover screwed on top of this, which means anything that's in the middle of the board you can't get access to without unscrewing the lid. Having the fuse accessible from the outside means putting it on an edge, the way I've done the USB connector down here. Get rid of that pop-up. Okay, so this USB connector here is aligned with the back edge of that curve of the bot. I could do a similar thing on this side, but there is going to be a space constraint. Henrik said, could you use add fuse between battery wire directly, not mounted on the PCB? Maybe blade fuse or a screw cap fuse. This is a blade fuse. This little horizontal mount, that's a horizontal blade fuse holder, which we will see. I'm going to update this so that we can see the surface mount fuse holder in this part of the design. Updating, rendering. Here we go. Okay, so this is what I just added. This is a little surface mount ceramic fuse holder, so you can clip in replacement fuses. This is the type that Austin has used on some of his projects, and it's pretty cool. I used this on the most recent, what was it, PCB conveyor controller board. I designed that into it. And down here, this is a mini blade fuse. So it's a horizontal mount mini blade. And my idea was to have that mounted here. But it is a space issue, how to make that work. And it also means that you end up with a fuse sticking out, which is not ideal. Embedded in a 3D print on the other side from the USB connector, says Simon. Yeah. That was my plan. But if you look at the size of that and the size of that, it's a problem. It's a problem. Let's take this, rotate it around here, change its angle to be, what is it now, 270. Let's rotate this. I can't remember what angle I used. Yeah, but look at the space here. The body of it intersects.
Are those fuse types obvious when they've let go? At Tinker001 said, that mini blade is massive.
Yeah, it is. Maybe what I need is something like a microblade. I've never used a microblade holder in a design, but that's probably what I should do. Let's make it 122 degrees. Yeah, about there. That is about on the edge of the PCB. So now if you can see that it's just overlapping with the hole and it is just overlapping with the motor driver. So are you going to update? Are you going to tell me you're going to update? No, come on. Are you lagging or are you just not noticing? Okay, it hasn't noticed there's an update.
That fuse can extract into the battery cavity.
Into the battery cavity. Ooh, maybe.
At Tinker001 said, try the SMT fuse in that location.
No, the problem is the SMT fuse is vertical axis, and you wouldn't really be able to get to it. So I need a horizontal axis fuse in that location. But Vic suggested into the battery cavity, so maybe, no, I think it'd obscure the cavity too much. Okay, now you've noticed there's an update. The battery cavity, yeah. Oh, I need to rotate it. I had it facing in exactly the opposite, exactly the wrong direction. Dunk, dunk. There we go. And back just slightly so that the pads are not overlapping with the edge. Okay, now do I have to save this every time before it's going to notice that it's got to update? Yes, I do. So I've got to go through the whole cloud storage save taking half an hour process instead of just Command S, done.
At Tinker001 said, if the socket is like the ones I've seen, can use a plastic tool to lever out the fuse from the side.
Oh, okay. Yes. So at this point, so this is with the blade fuse sticking out from that corner. The body of it is just about obscuring the hole, and at the other side of the body is sticking into this area here where the motor driver is, which could move. This could be made to work. Also, I could move this hole. So I could move these holes further towards this corner to clear that body. And it means that the fuse is easily accessible. Oh, you can see the socket there for the little idler on the back. So there'd be USB into the back right. You know, I just realized that I have forgotten something very important. What have I forgotten, people? Oh, Stephen says, are you just going to pull back a heap of copper core to have the ESP radio work in the middle of the PCB? Yeah, that was my intention. Pull back the copper all around this area and actually cut a hole into the PCB itself, so there isn't even any fiberglass near it. Leave it with a cavity around the antenna. So there'd be a hole in the bottom of the PCB right here, exposing the antenna. Battery? Lasers? No. Power switch. I was just looking at this thinking, okay, so we've got USB going in there, which could be used for charging. Fuse in here. How do we turn it on and off? UFL antenna. Yeah, you could do it with UFL antenna. The fuse in that position looks vulnerable. Can it be located elsewhere? Well, I'd like to locate it somewhere else. I don't know where.
The fuse in that position looks vulnerable. Can it be located elsewhere?
That worked. That worked. Crispian actually did TTS, and it worked. How? TTS never works for Crispian. Yeah, power switch. And it needs to be a moderately grunty power switch too, because it's a LiPo that runs through and drives these motors. So all of the motor power, it needs to be like a 1 amp plus switch, not just a titularly little thing. Magnetic reed power switch. Maybe? Okay, so this stuff has to fit in here. Oh, I'm tired. Oh, I think I need some lunch. I think you need some lunch. Only if
Crispian must have been rebooted, like Fusion.
Yeah, maybe. Yeah, anyway, that's where this is at. At least now I've got 340Ks on order. They'll take a little while to arrive, but they'll probably get here sooner than the PCBs. Even if I finish these PCBs today, which I'm not, I'm stopping now, and ordered them, the 340Ks would probably still beat them here. Oh, it'd be borderline. I could have the PCBs in a week. Mercury tilt switch for power. I don't think you can buy Mercury switches anymore. You can buy tilt switches, but they're really dodgy now. They're a ball bearing inside a tube. They're really crappy. The old Mercury switches were great. The modern ones, it's like a little crappy plastic tube with a ball bearing in it and a couple of contacts. They're rubbish. And they just rattle, like you can feel the ball move backwards and forwards in it. Not like the old Mercury tilt switches. It was so elegant. Ugh. Okay. Vic says, raise the motors and hide some SMTs underneath. I could make the whole thing thicker. At the moment, the height is dictated by the height of the motor. It is designed to be moat or height. The other thing I could do is, so there was a comment earlier about a vertical stack of PCBs. I could go double decker. I could make a module that plugs in on top of this.
Tinker001 said, guess I better guard the little box of mercury switches I have.
Yeah, Tinker, you do. Maybe that is a sensible thing to do. What I could, okay, hear me out, folks. See if this is a crazy idea. What I could do is, on the baseboard, on the main PCB, have the connection coming in from the USB going to the USB hub. I would have a USB to serial converter going to the ESP32 cam, and I would have the motor drivers and the power supply. That would all be on the baseboard, but I would not have the primary motion microcontroller. What I could do is put that on a little carrier board and have that plug in on top, because I've got vertical space here. I could put a row of headers here and a row of headers here and have the board plug in on top of it, and that would get the antenna for the main motion controller up away from everything else. It would give more real estate because it wouldn't be taking up this big chunk of space, and it would give flexibility potentially, because what I would do is expose the H-bridge outputs and all of that sort of thing. It'll give more flexibility to replace that board at a later date. So we could replace it with something other than an S3. I'm not sure. Vic says, I have in my hand a 22-gram mercury switch. Oh, yeah. Can you rotate the motors to vertical? No, because I want a flat plate underneath and I want a flat plate on top, so that we've got plenty of room on the deck, which is where accessories are going to mount on top of this. Because it's going to have a cover on it like that, and then there'll be other things mounted up on here, like a gripper that is mounted on the top and reaches forward to pick things up. I don't know. I've got to let this stew in my brain for a little while longer. What it feels like is that if I make a riser with the other parts on it, it needs to be more than just the S3 module, because it doesn't seem like a lot of point putting the S3 module on a carrier and then slinging it up on a subboard above this. To justify it, I would need to put more stuff on the subboard.
At Tinker001 said, upper level board upside down in that space.
Yeah. And Stephen says U-shaped PCB around the cam PCB. Yeah, it could be above the... There is room above the cam. It could sit up above it. And it could be a decent sized PCB. Like it could be a square PCB that fits into this cavity that is almost the size. In fact, it could be the entire size of that cavity in theory, and just sit above these other things. So it would sit maybe 7 or 8 millimeters below the top, and then it could have the module on it and all of the other things. So that's a possibility. I could effectively almost double my available board area by slinging a mezzanine board up the top here. But I would also need to move some other things up onto it. And I would want to keep the USB hub, the power management stuff, that really all should be on the main board. So I'm not entirely convinced about the idea of putting another board on top. But it's out there. It's an option. Okay, I'm going to go. I got to go because I'm going to go and say hi to my daughter. And gotta eat as well. I'm hungry. Hungry. Oh, actually, the motor drivers could go on up. Yeah, Steve. Well, the motor drivers are already out of the way. They are down here in these back corners near the motors. But Stephen is right. If the S3 module had the motor drivers on it, if the motor driver blows, you could pull that subboard out and replace it. Oh, and Tinker says, do look at that SMT.
At Tinker001 said, do look at that SMT fuse holder in detail for side access.
Yeah, this fuse holder here. I will consider that because that fuse holder in that position could be a practical way to do it. And then I still need to fit in a power switch. Do I have a to-do thing in here yet? I think I might. Yes. Link H bridges, add battery connection, add I/O connections for riser to top plate. Let's add into the to-dos. Let's add power switch. Power switch. Perhaps a subboard with the S3. Oh, on it? Yeah. Notes for future self. All right. I'm going to save that and get out of here. Because my daughter is doing she's performing this afternoon doing K-pop stuff. So I'm going to go over, see her, take her to the performance, take her to the venue. Yeah, okay. Oh, Vic says, put the rigid element of the printed frame in the battery compartment and those blocks of plastic on the outside can then have cutouts.
It has been good to share the squirrely fun with you all today. See you all next week.
Thanks, Crispian. Okay, I'm trying to parse Vic's comment here. Put the rigid element of the printed frame in the battery compartment and those blocks of plastic on the outside can then have cutouts. Let's see if I can interpret correctly what Vic is saying. I'm just going to close this off. Oh, come on, I was trying to... Why didn't it respond to the close? Okay. Yeah, cutouts in here. So rigid part. Put the rigid element of the printed frame in the battery compartment. And those blocks of plastic on the outside can then have cutouts. Yeah, these blocks, is that what you're talking about? Yeah, that's what I'm intending to do here. I've got the parts in there, like the USB-C connector, you can just see poking through, and there's going to be a cutout there, and then on this side there would be a cutout around the fuse holder. Yeah. Maybe I'm misinterpreting the comment, but I think that's what you mean, Vic. Yeah. Can you make the battery auto-eject if it catches fire? Probably not. Probably not. Anyway. Thanks for hanging out with Mr. Squirrel Brain. I am going to go and see my daughter. And I hope you have a wonderful Sunday afternoon, doing whatever it is that you do on a Sunday afternoon, or a Sunday morning for those of you of a European inclination. And I will... Oh, those two long bits alongside the battery compartment would no longer be needed. I'm looking at the design. I think those bits, I want them though, because it provides the guide for the battery compartment. Yeah. Okay. I gotta go. Thanks for coming. Remember, next week, same bat. Yeah, I should be here next week. I should be here next week. If I'm not, there is a reason I may not. I may be diving. I don't know. I would give it a moderate to low probability that I'll be diving, but it is possible. So if that's the case, I would see you in 2 weeks. But hopefully I will see you next week, and have a good weekend. Thank you very much. See ya.